this is our first conversation around Chapter 6, Momentum. And we'll be talking about momentum, impulse, how impulse changes momentum, bouncing, conservation of momentum, collisions, and more complicated collisions. Be sure to be looking at your vocab words. Use the Quizlet. Again, physics words might have a different definition or a different usage than language in everyday use. Momentum. Momentum, though, is pretty close to what you already understand. So to think about momentum, go back to Newton's second law, where we learned that force is equal to mass times acceleration, or the other way around, that we talked a lot about acceleration being calculated as the force divided by the mass. So we understand how force and mass and acceleration relate to one another. That's important. And remember, too, our definition of acceleration. Do you remember acceleration? That's the rate of change of the velocity. The first thing we have, for the first thing, we've got velocity. For the second thing, we've got, at first we have position, then we have velocity, then we have acceleration. They're all rates of change over time. So acceleration is the rate of change of the speed of something. The motion is changing, and that is its acceleration. This is a review of what we have done already. And what we can do is we could substitute those two accelerations. So in fact, we could say that force is equal to this mass times our acceleration, which we can also say as being the change in velocity. That's a delta v over t. Okay? Simple algebra. I can take my law, Newton's second law about force, and combine that with the detailed information about how we define acceleration, and then we can get something kind of complicated. Where another way to, when we combine these two, we in fact can say that force is equal to this combination of velocity over time. This is special. This idea of velocity over time we're going to use a lot of, and that is our definition of momentum. Velocity divided by time. Momentum is a property of moving things, and we couldn't quantify inertia, but momentum is directly related to inertia in that it is what it takes to stop something, or the force when a moving object hits us is related to momentum. It's the mass of an object multiplied by its velocity. And here is our equation for momentum. This is what you need to memorize. This is part of your definitions. And the unit for momentum is kilograms times meters divided by second. What does momentum really mean? Well, this is one that you already understand. So if we have a small mass and a moderate speed, and here we've got a picture from the Cartoon Guide to Physics of a baby stroller getting away from somebody, and it's only got a moderate momentum. There's only so much it's going to do to us. It's not going to take a whole lot of force to stop it or to slow it down. All right? Compare that to something very, very massive like a Mack truck. And in fact, when we start calculating things, the Mack truck has a momentum, this is kind of funny, of a baby carriage going 1,000,000 miles an hour. All right? So the momentum of something is the combination of its mass and the speed that it is going. That is momentum. couple more examples. In this case, we're saying that our boulder is really, really big. So it would have much more momentum than a stone, which we would say is small. If we let them go at the same time, the boulder has more momentum. All right. A boulder going fast has more momentum than a slow boulder. So if it's the same mass, but one has greater speed, it will have more momentum than the slow boulder. And if we have no motion, we have no momentum. That's the third thing to remember. If velocity is 0, if nothing is moving, then we have no momentum going on with our object. All right, think about this for a minute. What does a moving object have? Does it have momentum? Does it have energy? Does it have speed? Or does it have all of the above? Well, in this case, the moving object does have all of the above. We will not look at energy until a future chapter, but energy and momentum are related to each other. How about another one? Suppose that we have an object and its speed is doubled. What happens to the momentum? Recall that momentum is equal to velocity times mass. And we actually will give a different letter for momentum. But momentum is equal to velocity times mass. So what happens when the speed of an object is doubled? Does nothing change? Does the momentum double, quadruple, or does the momentum decrease? All right. When the speed of an object is doubled, its momentum also doubles. And I hope you caught this. We're really saying when the velocity. Because if we don't indicate the speed, the direction of the speed, we could have some canceling effects. So more correctly, that would be when the velocity of an object is doubled, its momentum doubles. That's it for the first section in your book. See you soon.